All right, guys, this is to help you guys out with your AP Practice Test 1. If you would rather just redo it rather than wait for your next AP Practice Test score to improve it, you can do that. I kind of like this idea because this way you guys get to be exposed to more types of problems and how to solve them, so please take advantage of it. All right, well, let's go ahead and begin here. So once again, you really just need to fast forward this video to the parts that you got wrong because those are the only ones you need to redo on your test. But without any further ado, let's go ahead and get started. So for number 1 here, what you should have done was a chain rule. So what we would start off by doing is multiplying the front by the exponent of 5 and not changing the inside. And then the exponent would get decreased by 1. That's the derivative of the outside. And now we're going to multiply it by the derivative of the inside. So if I take the derivative of that inside, 2x to the 4th would become 8x cubed, and the 13 just goes away. And then finally, if I just multiply these two things together, I'm going to end up with 40x to the 3rd times 2x to the 4th minus 13, all to the 4th power, and that would be this guy right there. Okay, now I know this may not be your version of the test, but that's okay. Every question is a similar type of problem, so that your problem would be done in a very similar way. All right, let's go ahead and take a look at number 2. So the table below gives the velocity in miles per hour of a truck. It's selected times t in hours, and we're going to use a trapezoidal sum with the 3 subintervals indicated by this table, and we want to approximate the distance in miles that the truck traveled from 0 to 3.5. All right, so trapezoid sums work like this. The distance from here to here is a height. So my first height is 1, my next height will be 1.5, and my next height here will be 1, and I'll just put an h here to represent heights. The ones down here on the bottom are the bases. So for my first trapezoid, it's going to consist of the 2 boxes here. Matter of fact, I'll draw it a little bit differently. There we go, to make like a little house shape. These are my bases, so it's going to be 12 plus 45 multiplied by the height over 1. I'm sorry, over 2. My next trapezoid will be the next 2 bases combined with that height up there. And so that one's going to be 45 and 60 multiplied by that height, which is 1.5 over 2. And the next trapezoid will be the last 2 bases, which are 60 and 55 multiplied by that height over 2. And then from here, we're just going to go ahead and use our calculator to simplify these. If I add and then multiply it by these fractions in the front, we'll see what we get there. And so that's the area of each trapezoid. And then when you go ahead and you, oops, let me fix that. And when we go ahead and add all those up, we end up with 164.75. And that would be a trapezoidal sum to estimate the distance that the vehicle has traveled. Okay, go ahead and move on to number 3. So for this one, they give us a function and they want us to find the derivative at the specified value. So we're going to start by finding the derivative. Once again, this is a chain rule. The derivative of cosine is negative sine. And then the derivative of the inside here will be 2x. The pi is just a number, so that just goes away when you take a derivative. And now we're going to go ahead and plug in the number that they give us, which is the square root of 2 pi. And when you square the square root of 2 pi, the square root and the square cancel. And so we have 2 pi left minus pi, which is pi. And sine of pi is 0. So we have 0 multiplied by this, which is just going to be 0. So the answer on this one will be 0. Okay. So basically, find the derivative using the chain rule, and then plug in the point they give you. Move on to number 4. All right, so they give us a function here, and they ask for the average rate of change. Average rate of change can be found by doing this formula here, like that. So I need to, well, simplifying the bottom is pretty easy, right? 3 minus 1 is 2. But we have to do the top. We have to figure out what's g of 3. To do that, we're going to plug 3 into our function. And that's going to be negative 45 here plus 27. I'm going to go and use my calculator because I'm being lazy. Why not? You guys get to use your calculators on it for now. All right, so that's negative 18 minus, and now we're going to do g of 1. So let's plug in 1. Negative 5 plus 1, which is negative 4. Double negative becomes a positive, and that leaves us with negative 14 over 2, which is negative 7. So basically just find the average rate of change. It's y2 minus y1 over x2 minus x1. Let's take a look at number 5. All right. So this one, there's a lot to look at, but what you want to pay attention to is these limits. So this one goes from 2 to 5. Now you're going to notice that that's backwards. So right away, let's go ahead and fix that. Put the negative 5 down here and the 2 up here, which I'm allowed to do. But if I do that, that ends up putting a negative in front of it. Okay? So in other words, this thing is going to be the same thing as this. It's just that it's going to be changed to an opposite sign. Matter of fact, let me put a negative in front of that. That's going to be the same thing as this, right? It's just that it's got an opposite sign now. Okay, now we know that the original one is negative 5. So if this one's the same thing but just with an opposite sign, that means it's going to be 5. So let's go ahead and write that. So now we know that this one flipped over is going to be a positive 5. So if this one equals negative 5, then this one has to equal positive 5 because they're opposites, right? We flipped the integral there. All right. Now that being said, the rest of it will kind of fall into place. So now the next one here goes from 2 to 4. And that one's 7. And now what they're asking for over here is they're asking for one that goes from negative 5 to 4. So what does that one equal? Well, if going from negative 5 to 2 makes 5, and then picking up from there and going to 4 makes 7, we could just put those together to get a total of 12. Okay, that relates us back to an old property that we learned a little while back that looks something like this. It's just that before we get to use this rule, you have to reverse this one so that the smaller numbers on the bottom and the bigger ones on the top. And so our answer will be 12 for that. All right, let's go ahead and move along to the next question, number 6. So this one's asking for an equation of a tangent line. We know we need a slope. We know we need an x. We know we need a y. They've given us an x. And they've given us a y. We need to find a slope. And to do that, you need to find the derivative of this thing. Now, e to the x over 4, maybe a nicer way of thinking of that would be e to the 1/4 x. Maybe right. So when we take the derivative of an e function, we always get the same function again, but we do need to multiply it by the derivative of the inside, which is 1/4. Now, to find the slope, we have to plug in the x value that they gave us, which is 4 ln of 5. So let's do that. We have our 1/4 in the front. We have our e, and it's going to be 1/4 and then 4 ln of 5. Now the 1/4 and the 4 cancel each other out. The e and the ln cancel each other out, and I'm left with 1/4 times the 5. That's all that's left there. And so my slope ends up being 5/4. So I'm looking for a tangent line with a slope of 5/4, which could be one of these two now, and an x value of ln of, or 4 times ln of 5, which would be this one, and a y value of 5. So therefore we can see that the answer here would be E. Move on to number 7. Number 7 here is going to be a U-substitution type problem. So let's go ahead and start there with that. So first I'm going to say that u is equal to 2x squared plus 4. I'm going to take the derivative of that with respect to x, so that's going to be 4x. And then we're going to get dx by itself, which will look like this. Then we're going to go and do our u substitution. We're going to have x times u to the 1/2 du over 4x. And the x's cancel, and I'm going to go ahead and throw this 4 out to the front as a 1/4 there. Now we also need to rewrite our limits. Okay, so you're going to plug in radical 6 to figure out what the u value will be that replaces it. So if I take a square root of 6 and I square it, I get 6. 6 times 2 is 12, plus 4 is 16. Plug in 0. 0 squared is 0, times 2 is 0, plus 4 is 4. And so now I've got a much simpler looking square root. It's not square root, integral, which looks like this. From there, we're going to go ahead and just do integration as usual then, now that the U-substitution piece is all taken care of. So to integrate u to the 1/2 power, we're going to add 1 to this power, which is going to make it become u to the 3 over 2. Put our 16 and 4 here. We still have our 1/4 there. You're also supposed to divide by this power, but when we divide by a fraction, that's the same as multiplying by its reciprocal. So I'm going to multiply out here by 2/3. Multiplying these together, the 2 and the 4 can reduce. So I'm going to be left with 1/6. And then we're going to go ahead and plug in what they give us here. I'm going to plug in 16. And I'm going to plug in 4. Now, how do you do this? Well, it might help if you remember how to change this into a root. So 16 to the 3/2 power, that's the same thing as the square root of 16 being cubed. So the square root of 16 is 4, and 4 to the 3rd power is 64. So I've got 1/6, and that's going to be 64. As for this one, same thing. Take the square root and cube it. The square root of 4 is 2. 2 cubed is 8. Let's go ahead and do our subtraction here. 64 take away 8 is 56. And then this can be reduced. We get 56 over 6, which can be reduced to 23 over 3. Or, I'm sorry, 28 over 3, my bad, which will be option B. All right, moving on to part 8. This is an ln, well, I'm sorry, it's a U substitution problem. So let's go ahead and do U sub on this one. Okay. So my u will be the entire denominator. The derivative of u with respect to x is 2. So du over 2 equals dx. And this would be du over 2, but I'm going to put the over 2 in the front now instead. The integral of 1 over u is ln of u. And the u was 2x plus 7. So our final answer there is 1/2 ln of 2x plus 7. So it's a U sub problem that results in an ln. Go ahead and take a look at number 9. So the graph of a function f is shown below. Which of the following expressions Which of the following expresses the relationship between these three integrals? So let's color code these a little bit. This guy here, from -2 to 0, that's this shaded region here. Next, from 0 to 3 is this region here, this area. And this one here is what you'd get when you put them together. Now, going from -2 all the way over to 3. So that's the whole thing. And you might think that the red one's bigger, but it's not. And here's why. Because this is a negative area down here, and this is a positive area. Okay, so the negative one's going to be the smallest. The positive one's going to be the biggest. The red will actually be in the middle. So think about this for a second. Suppose, this area here, let's just say it was 4. And this one down here, we'll say it was -2. -2 would be the smallest, 4 would be the biggest. And if you combine them, they kind of average each other out and give you something in the middle, right? And so in this case, the green is the biggest, the black is the smallest, the red is the one in the middle. So the black one's from -2 to 0, that's the smallest. And there's only one that has that, so we can already see right here that that would have to be the answer there. All right. Go ahead and move on to number 10 here. A lot of people didn't do too hot on this one. This was a very commonly missed question. Let's go ahead and review it. So first of all, you have to take the derivative of this thing with respect to x. Now this is going to be implicit differentiation. So if you take the derivative of an x term, you just take the derivative like you normally would. But when you take the derivative of a y term, you have to put a y prime in there, okay? Now this is a product rule. So I like to let's put those in brackets there. It's going to be a times b plus a times b, right? I'll label it. You don't have to label it if you don't want to. Where we do prime on one and prime on the other. So a is going to be x. If I take the derivative of y, it's just going to be 1y prime. If I take the derivative of x, it's just going to be 1. That one's not going to have any prime with it because these match, the x here and the x here. And then the y stays the same here. Minus, take the derivative of that, you get -4. But since there's a y, we get a y prime factor multiplied by it. And then over here we have 0. Now, I'm going to go ahead and rewrite this just so it's a little bit less befuddled looking. All right. Now, at this point, what you can do is the way we've done it before is you get the y prime by itself, but actually you could just go ahead and plug these numbers in now for x and y, not for y prime though, just for x and y, and you could solve for y prime. I think I'm going to stick with the old way though and just get the y prime by itself first. So let's do that. But you could plug the numbers in first and then get y prime by itself. It's up to you. So the way you get y prime by itself is anything that has a y prime is going to be on one side of the equation, so that's these two, and the other two will move to the other side. So I'm going to leave x prime and -4y prime on this side, and I'm going to subtract this one and this one to the other side. Okay? Now, what we want to do is we want to factor out the y prime on the right side. Both terms have a y prime, so I'm going to factor that out of there. Just like that. And then you're going to divide both sides by the x minus 4 in parentheses there. And so now we've got an expression that represents y prime, which is the derivative. This is another way to write y prime. And so I've got -2x minus y over x minus 4. And at this point, I'm going to go ahead and plug in my numbers. So we have -2 blank minus y over blank minus 4. Now the x value is 1, so I'm going to plug that in here and here. and the y value is 2. And so I'm going to end up with negative 4, it looks like, over negative 3. The negatives cancel because they're both negative, and I'm left with 4/3 as my slope. So that's how you find the derivative at a specific point for a function in implicit notation. So that was a commonly missed one. Let's go ahead and move on to our first FRQ question. So we have a particle moving on the x-axis with this velocity, and we have an initial condition given by x equals 3 at time equals 0. So they want us to find acceleration. Now, acceleration is equal to the derivative of your velocity. So if you wanted to find acceleration, you need to find v prime of 1. Now, a lot of you guys did this by hand, which is fine. I saw a lot of students doing the low d high minus high d low, which is totally awesome. Some people got the right answer by doing that, but a lot of the questions on this particular problem are geared more so towards a calculator. So I think I'm going to go ahead and just do it on my calculator. But you're welcome to do low d high minus high d low, draw a line and square below, and plug your number in. And my advice to you is if you're going to go that route, don't work it out. Just do low d high minus high d low, plug your number in, and leave it. Because if you get one little minus sign wrong, you lose it. So just plug it in and leave it alone. Don't work it out. Now we've got to be careful typing this stuff into our calculators. So remember, since my fraction here has more than one term on the top, my top is going to need parentheses, and my denominator, since it has more than one term, is also going to need its own little set of parentheses. So we need to do x squared minus 8x, and I think it was plus 4, divided by 3x plus 5, I believe it was. Let me double check this to make sure. Yes. All right, so there it is. I'm going to go ahead and get out of there. And I'm going to find out what is v prime of 1, the acceleration. Once again, I'm just going to do this on my calculator. My calculator do the work for me. I'm going to do math. I'm going to do 8. I'm going to do x here. I'm going to put my function, which was y1 here. Oop, that didn't go in the right spot at all, did it? Let me go back and put it in the right spot. There we go. And I want to find the derivative at 1, so I'm going to plug 1 in here, and there's my acceleration. And that's it. That's all you have to do is write down that number and this, and you're good to go. That was a 1-point question. So let's go ahead and move on to the next one. Find all values of t on this interval where the speed of the particle is 0.5. Ah, yes, okay. We had one like that on our FRQs that we went over today. You guys are probably thinking, man, Mr. Bailey, it'd be nice if you'd have shown that to us then. Sometimes you're just going to have to learn how to think outside the box a little bit. All right, so now on this particular problem here, speed is the absolute value of velocity. Now, they want to know when does that equal 0.5. So in other words, they want to know when does v of t equal 5 and when does v of t equal negative 5. Because if the absolute value of v of t equals 0.5, I should be saying 0.5, not 5. If the absolute value of v of t is equal to 0.5, then that means that v of t can either equal a positive 5 or it can equal a negative 0.5. Okay, so now here's how we're going to solve this. I'm going to graph my v function. So let's just say it looks something like this. Okay, now once I graph it, I'm going to also graph the line 0.5, which maybe would look something like this. And everywhere where my velocity function touches 0.5, that means that's where the velocity equals 0.5. So I'm going to find where those intersect. After I do that, I'm going to get rid of it. And I'm also going to find everywhere where it touches a negative 0.5. Okay. Now, what's important here is to understand the interval we're working on. We're only going from 0 to 3. So when I graph this, I only want to look at a viewing window that goes from 0 to 3. So here we go. Let's take a look at our graph. But first, let's adjust our window. I want to go from 0 to 3. And then let's graph it, see what that looks like. I don't like how flat this is, so I'm going to zoom in a little bit. I don't need this much y on the bottom and top. So I think I'm only going to go from y equals 2 to y equals -2. So let's adjust our window one more time. When it looks that flat, it's really hard to see stuff. So we're going to go from -2 to +2. And that way just be a little bit easier to see when we're working on it. All right. So now that's the graph of my velocity, but now I also want to graph 0.5. So let's go down to where it says y2, and I'm going to type in 0.5. All right, now you guys can see right here, this is one place where the velocity equals 0.5. So let's find where those two things are crossing. So we do second, calc, and 5 for intersect. And we're going to scroll our cursor to where they cross. And then we're going to push enter 3 times to get a very precise answer of 0.161. So that's one point in time where the velocity is equal to 0.5. Let's see if we can find the other time when the speed is equal to 0.5. And that would be when the speed or the velocity equals -0.5. So let's do that. Go back to our y equals. I'm going to go ahead and delete this 0.5 here, and I'm going to put in its place -0.5. Now let's graph that. And here, the velocity equals -0.5 also. So it would be at 5. Enter 3 times. And we have 1.234. That's an interesting number, isn't it? So there you go. So those are the two places. On this one, there was no explanation, no justification. I was giving points for just having the answers, but it might be good to do this. Oops, not prime, my bad. Just to show your AP readers that you know you're looking for the place where the velocity equals 0.5 and where the velocity equals -0.5. And you could do this also. This is the shorter way of writing this. So that would be nice to have on your paper, but honestly, I'm just giving you the answers myself for just having this here. But on the real AP test, probably be good to do this. It's just that I didn't think to grade it like that, and I just gave 1 point for each correct spot. Now, on some of the versions of the test, I asked about speed. And for speed, you have to look at positive and negative. But if I ask about velocity, then you just do the one that they ask you. So on some of the tests, for instance, I might have just said, find when the velocity equals 0.7. Well, if I'm just asking about velocity and not speed, then you don't do the positive and the negative one. You just do the one they ask for. So that's pretty much it. All right. So that being said, let's go ahead and move on to number 8. I don't know why I said 8. We're on part C. All right. So now for part C, there's a lot going on here. It says find the position of the particle at time 2. So we need to start by finding the position. Okay. Then they want to know, is the particle moving toward the origin or away? Now, a lot of you guys tried to answer this question without doing something that's very important. Let me kind of illustrate this for you. So let's just say I have a number line. It's moving along an x-axis. The particle's moving along an x-axis. And let's say the origin's right here. And let's say the position at t equals 2 is like right here. Well, if it's there, then if it's going to be moving towards the origin, then it would have to be going left. But what if its position was here and it was still going left? Well, now it's moving away. So my point here is that you can't just know the position and have enough information to know whether it's moving towards the origin or not. You have to know the position and the direction it's traveling, both at once. Now, how do you know which direction the particle is traveling? Well, you know the direction by looking at the velocity. Okay, so you need to look at the object's position, you need to look at the direction it's traveling, and then you can explain whether it's moving toward, or away. So, how do we find the position? Well, if you want to find the position of a particle using the velocity function, you're going to take the particle's initial position, which I think I forgot, so I think up here it says it's 3. All right, so the particle's initial position, sorry, let me scroll this down to where it needs to be. There we go. The initial position of this particle is 3 plus the integral from 0 to 2 of velocity. Now, I'm going to go ahead and punch that into my calculator, and I'm going to see what I get. And I end up with negative 1.073. Now I want to do the direction. And like I told you, to get the direction, you have to do the velocity at that number. So what direction is the particle traveling at 2? So once again, I'm just going to plug 2 into the function for my velocity. And for that, I've got 0.25, well, it's about 0.260. Now, all that matters is that that's a positive number. And since it's a positive number, that means the particle is moving to the right. So now let's plot this on our number line up here. My particle is located at this coordinate, so at negative 1.073. So that would probably be like right about here. And it's moving to the right. So you tell me, is that moving toward the origin or away? Well, it's moving towards it. And so there's your explanation. So you would say, since the particle is located at negative 1.073 and moving right, it is moving toward the origin. Now, the way this one was graded was you got 1 point for finding the position, 1 point for finding the velocity, and then 1 point for your explanation, for a total of 3 points on that particular problem. All right. Let's go ahead and move on to part D. All right. So basically what I want to do for this one is I want to find, okay, well, the particle started at x equals 3. And on this time interval, does it ever go back to the x coordinate of 3? And how would we know? The way we're going to do this is a lot like a candidate's test. Okay, we're going to find the position of this particle at some critical points. And we just want to see, where did the object move to on this interval? So we're going from 0 to 2 only. And we also want to find our critical values. Now, the critical values are where this function has a derivative that equals 0. And the derivative of x is just the velocity function. So where does the velocity function equal 0? Well, that would be where the velocity function touches the x-axis. So for that, I'm going to look at my calculator. I'm going to do a couple things with this here. First of all, I'm going to go to y equals. I'm going to get rid of that negative 0.5 because I don't need that anymore. I just want to get that out of the way. Next, I'm going to go to my window. And I just want to look at the interval that I care about, from 0 to 2. I don't want to go too far. So let's go ahead and regraph it. So I only have one critical value, one place where the velocity equals 0, which is right here. So I need to find that value. So we're going to do second, calc, 0, and we pick a point to the left of it and a point to the right. So my calculator can zero in on that intercept. And it's about 0.536. All right. So we have 0.536. Now I know the position at the beginning is 3. After that, the particle is moving to the right. And then after that, it starts to move to the left. And the question is, will it go back? Now, honestly, you can kind of tell just by looking at the graph that it will, because the area under this curve tells you how far to the right it went, and the area under this curve tells you how far to the left it went. Well, if I started at 3 and I move to the right this much, and then I start moving to the left this much, well, this area is a lot greater than this area. So yes, eventually it's going to take you right back to where you were. But we want to be a little bit more specific with our answer than that vague explanation. So we're going to go ahead and find each of those little spots there. So let's go back to our home page here. And what I want to do is I want to find each one of these values. So I want to find x of 0.536. and I also want to find x of 2. And to do that, we're going to use the x function, or the position function, which is 3 plus the integral of velocity from 0 to whatever time you want. And so we're going to plug this in here and find our answer. We're going to plug this in here and find our answer, and we'll see what we get. Okay, so these are the answers I get by doing that. And now, as you can see here, my particle has traveled from 3 to 3.9, so that's when it's moving to the right. And then from here to here, it's moving to the left. Okay, so now if I'm going from 3.19 to 2.508, then yes, I would have to reach a place where x equals 3 again, because that's the intermediate value theorem. So this problem is kind of like a combination of doing something similar to a candidate's test that's actually pretty much identical, but in conjunction with an IVT. So what we would say here is we would say, since x goes from 3.19 to 2.508 on the interval 0.536 to 2, that's the t values over here, there must be some time t where x of t equals 3 on that interval. And so yes, at some point, oh, and why do I care about it equaling 3? Because that's the starting place. So the question is, does it ever return to its starting point? In other words, does x ever equal 3 again? And the answer is yes, because as I go from 3.19 to 2.508, I have to cross 3. And so there is our final answer there. Since x goes from 3.19 to 2.508 on this interval, there must be some time t where x equals 3. So part D on FRQ1 is a combination of a candidate's test plus an IVT question. On this particular question, I forget how many points I actually made it. It was either worth 2 or 3, but I would need to see these numbers and your answer. Okay, so that'll do it. All right, let's go ahead and move on to the next FRQ. Now, most of you guys did the slope field pretty well. It's just that you might have gotten like one of the points wrong. Usually these are only worth 1 point, but I made it worth 2. So if you got really close, I gave you 1, but if you were off by a lot, you didn't get any. So you have to be kind of close. Just to kind of review this with you, I think all of you guys know how to do this. But you want to know, a really common error I saw was that some of you guys didn't catch the fact that, well, like this point, for instance, -1, 0. You would be plugging in -1 for x and 0 for y. And so anytime one of the numbers you plug in is 0 and you're multiplying everything, well, that's just going to be a flat horizontal line. Now, if you're dividing by a 0, that's going to be a vertical line. That's undefined. But whether I'm on this axis or on this axis, either way, I'm going to be plugging in a 0 for the x or y. So all of these points should have, on this one, should have had a flat slope. Now, you might have had a different test with different setup here, but for this particular one, since plugging in 0 will give me a 0 slope, those are all the same. Okay. As for like this point, for instance, I saw a lot of people when they did miss one, they usually missed one on the negative side also. So it was either on the axes or on the negative. So you guys kind of got to watch your basic math there a little bit. So I'll just do one of these really quick. 2, in this case, x is -1 and y is 2. So if I were to do this, it would be -2 times 4, which is -8. So what I'm looking for is a really steep negative slope there, because 8's a pretty steep slope and it's negative, so it's got to be going down. But in any event, watch your signs, okay, and watch out for zeros. That was the 2 biggest errors I saw in this part A here. So if you got 1 point, then one of your points were off, and it was probably only one. It could have been 2 or 3 even. But if the majority of your points were good, then you got at least 1 point. But if the majority of your points were wrong, you didn't get the full point. Let's go ahead and do part B. Write an equation for the line tangent to the graph of f at x equals 1. So to find a tangent line, you need these 3 things. All right. This is where you get your slope from. Okay. My slope is the derivative. Now, you don't find the derivative of this. Some of you guys found the derivative of this. Now, if you think back to one of the problems on the multiple choices, we did have to find the derivative first because they gave us the f of x function. And so if you want the slope, you need the slope function to do that. But this is already a slope function, so you don't take the derivative of this. Because as you guys can see, it's a derivative already, right? So we don't do that. You just leave it just the way it is. So we're going to plug in -1 for the x, and we're going to plug in 2 for the y. All right. So now that's an important detail to pay attention to. On some problems, you're going to be given the actual f function. For those ones, you do need to find the derivative first. But if they're giving you a problem where they already give you the derivative, if they ask for a tangent line, then you have your derivative already. Don't take the derivative of it again. And besides, for most of you guys who did the derivative, I don't think anybody did the derivative correctly because this, for instance, would have been a product rule. And a lot of you guys just multiplied the 2 to the front and we're done. You can't do that. So, but that's beside the point. So in this case, don't take the derivative, just plug in the point. Anyway, we end up with -8 here for a slope on this one. My x value is -1, my y value is 2, and at that point we just plug it into our point slope formula. Slope goes here, x value goes here, y value goes here, and call it a day. Stop while you're ahead. Okay? Watch out for those double negatives. The formula has a minus, but I'm plugging in a negative, so you have double negatives there. Some of you guys went ahead and changed it to a positive, which is fine. Just be careful. All right, let's go ahead and take a look at part C. All right, so part C is where all the points are located. Okay, this is where you get all your credit. So you want to pay close attention to part C. A lot of points to earn here. So the first step on part C is to separate your variables to get all your x's on one side and all your y's on the other. So the first thing I recommend doing usually is multiplying both sides by your dx. I put 2x is supposed to be dx. And that way these cancel and I have this. The next thing you want to do is you want to move the y to the other side. Now sometimes you'll multiply, sometimes you'll divide. It'll be one of those two things. And in this case, since the y squared is already in the numerator, we're going to divide it to cancel it out. And so what I end up with as a result of doing all that is the following. I have 1 over y squared dy is equal to 2x dx. Now this guy here, I'm going to go ahead and rewrite that as y to the -2. If it was a first degree power instead of a 2, I would have left it on the bottom because that's going to be an ln in that case. But since it's a power of 2, you're going to change it to a negative exponent move to the top so we can just do the power rule. All right, now we're ready to integrate. Some of you guys did have an ln problem on your test. Some of you did not. This is one that's not because, like I said, this is not a 1 over y. This is a 1 over y squared. So for this one, we actually have to do the power rule. Now, every test was a little bit different with the integration. So here, all I could say is basically know your integration. But for this particular one, we add 1 to the power, and we divide by that number. This one, same thing. Add 1 to the power, and divide by that number. Now, if I divide 2x by 2, the 2's cancel. So I'm just left with x squared. We don't want to forget our c. And I'm going to rewrite this so it's a little bit less weird looking as that, because a negative exponent will put the y on the bottom, and dividing by a negative just makes the whole thing become a negative. So that side becomes -1 over y, and this side is x squared plus c. Now just to kind of let you guys know how points are given here, I've said it many times before, but I'll remind you, separating the variables is 1 point, and integrating each side is a point. So you would have gotten a point here and a point here, so that's 3 already. The next point is to find your c. So you're going to plug -1 in for x and 2 for y in this case. and I end up with negative 1/2 equals 1 plus c, and I'm going to minus 1 on both sides. Now, if you combine these, I'll let you guys do your basic math there, but you're going to end up with negative 3/2. Okay, so my y value in this case turns out to be negative 3/2, or my c value, I should say, comes out to be negative 3/2. And if that's my c value, I'm just going to plug that in now. Now, the first thing I'm going to do at this point is I'm going to multiply everything by a negative to get rid of the negative in front of the 1 over y, which is going to give me this. And then I'm going to take the reciprocal of this side, which means I'll also have to take the reciprocal of this side. And that's it. Just put that whole thing over 1, you're good to go. Now remember, at this point also, depending on what test you have, you may have to do some different steps. If you have to know that to get rid of an ln, you exponentiate both sides, or if you want to get rid of an exponent function, you have to ln both sides. So you have to know some of those basic processes to solve. But the steps are still the same. It's separate, integrate, find c, solve for y. Finding c qualifies as the 4th point, and then getting your final answer qualifies as your 5th point. And that's all 5 points there. So hope that was helpful, and we'll see you guys in class.